Hi, and welcome to this screencast. We're going to be talking about special situations with binomials, and then we'll be looking at how to find the zeros of a function. So numbers 1, 2, and 3 are looking at different special situations. So in example number 1, you have x plus 2 times x minus 2, or x plus 6 times x minus 6. And then if you notice, the first term is the same in both binomials, and then the second term is the opposite, or the additive inverse. So x and x is the first term in both these binomials, and then the second term is 2 and negative 2, 6 and negative 6. 2x and 2x are the same, and then the 1 and negative 1. So because of that, what you're going to have when you actually use FOIL to multiply it out is you'll end up that the middle term disappears because they will negative 2x plus 2x equals 0. So you'll have no middle term, and this will be what's called a difference of squares. Then, number 2, this is the one that most people mess up because they think x plus 3 squared must be x plus 9. But that's not true. When you actually multiply it out, you have to be careful because you're really multiplying x plus 3 times x plus 3. So when you use FOIL, or you multiply the two binomials, you end up with the trinomial with this middle term of 6x. So you have to be careful that when you do x plus 7 squared, that's really x plus 7 times x plus 7. So that's why you end up with the 14x in the center. And then the second situation is like the first. It's just the only difference is that you have negatives. So the middle term is a negative. Okay. What I want to do is practice a little bit. So one example to practice from is number 32 here from your textbook from 8.3. And let's try that example. So you want to copy down negative x minus 2y. That quantity is being squared. So let's rewrite that as two binomials. And so I have negative x minus 2y times negative x minus 2y. So when you multiply this out, you could use FOIL, which would be a good way. Remember that when you multiply the first terms, it's negative x times negative x. So that gives you a positive x squared. And when you multiply the outside terms, you'll have negative x times negative 2y. That's a positive 2xy. So go ahead and finish that. And this is what you should have at this point. So pause the video and simplify this polynomial. So we would have x squared plus 4xy plus 4y squared. And that would be what's called the expanded form from the original factored form. Yay. So now let's look at number 35. So in number 35, they're asking us to multiply the two functions. It says f of x times g of x. But they tell us that f of x equals 3x plus 0.5 and g of x equals 3x minus 0.5. So if I come down here and I'm going to multiply the function, then what I'm going to do is, I wrote f of x times g of x. I'm going to substitute what f of x actually equals. So f of x is 3x and g of x is 3x minus 0.5. So now I've just substituted in the values I know, and what you would do from here is you would actually multiply. You could use FOIL or whatever method to multiply these two binomials and get a final answer. So pause the video and do that now. So you may have noticed that when you do this, we should have noticed that the middle term cancels out because you have the outer is 3x times negative 0.5, so that gives you negative 1.5, and the inner is positive 1.5x. So they are going to cancel out, and so you end up with a difference of squares as your answer. Now, in the next two problems, 36 and 37, are kind of the same. Now what you're going to do is you're going to square each function. So you're going to square f of x. So if I'm going to square f of x, then what that means is I'm going to take the entire binomial that is f of x and I'm going to square it. So that'd be 3x plus 0.5 and I'm going to square that. But I'm going to be careful to remember that doesn't mean I square each part. Instead, that means I'm multiplying the binomials 3x plus 0.5 times 3x plus 0.5. So I'm multiplying that binomial times itself. I'm not just distributing that squared. So when you do this, you're going to get an answer. Go ahead and try that, and pause your video. So you would get this 9x squared plus 3x plus 0.5. Now, if I do 37, now I'm going to be squaring g of x. And if we look at the function g of x, and we're going to square that, if we compare that to the function f of x, notice they're almost the exact same. 3x plus 0.5 minus 0.5. So the difference is this positive, when I square it, becomes a negative. So how will that affect the problem? Well, this will be negative here, and this will be negative here in number 37. And so how will that change the polynomial? Well, it's not going to change the first term. It's still going to be positive 9x squared. It's the middle term that will change because both of the outer and inner are going to give you a negative 1.5x. So that means the 3x becomes negative 3x. Let's right over top of that. Negative 3x, but it's still positive. Oops, I had the wrong answer before. That was should have been 2.5. My apologies. That should have been 2.5 for the other one also. So what we wanted to look at here is how you can see function notation as a way to ask you to square and multiply polynomials. Well, we're not finished quite yet. Let's look at how we can, an introduction to solving polynomials. So what we're going to do is we're going to put this function in the graphing calculator, x plus 1 times x minus 2. So we're going to look at this product of two binomials, and we're going to create a graph. Now, we used graphs before in the graphing calculator to test our answer. So let me show you how you would do that also. I'm going to hit enter, make that a thicker line, and I'm going to type in, I think that this would equal the trinomial x squared, and then I would get minus 2x as the outer term, plus x as the inner term, so it's going to be negative minus 1x, and then 1 times negative 2 is negative 2. But let's say I was wrong. Let's say I thought it was positive 2. Let's see what happens if I had the wrong sign when I multiplied. This is what it would look like in the graph. Here's the first graph. Here's the second graph. So I can tell my answer is wrong. I multiplied incorrectly because they don't overlap. So if I had the correct polynomial, and I'll fix that to make that minus 2. Now I'm going to graph it, and you'll see that the first one and then the second one, they overlap. So that's one way to check your answer using a graphing calculator. But I'm going to clear this out, and we're just going to talk about this function here in the factored form. So when I graph it, you're going to notice that you should see that it hits the y-axis one time, but the x-axis twice. And where it hits the x-axis is called the x-intercept. You've heard that before, but it's also called the zero of the function. So the zero of the function is where the y, or the function itself, equals 0. And that's at where x is negative 1 and where x is positive 2. So you may notice that in the function here, we have x plus 1 and x minus 2. Well, think about this. If I put negative 1 in for x here, then I would have negative 1 plus 1 is 0. And so if I multiply by 0, my whole function is 0. If I put 2 in for x, 2 plus 1 is 3, but 2 minus 2 is 0. So 3 times 0 would equal 0. So that's why those two values, negative 1 for x and positive 2 for x, will result in the 0 of the function. So what you're going to do is you're going to use the zero product property, that anytime you multiply a number times 0 equals 0, you're going to use that fact to solve polynomial equations. So let's look at a couple simple ones now. and then we'll see how we're going to do that. So this is examples. This is number 7 from page 520, and there's a whole section on page 520 of different examples like this that you could try. So I'm going to start with, what I'm going to do is, if this binomial, if I can get that to equal 0, then I would do 0 times this one, and it would equal 0. If I can get this binomial to equal 0, then that means 0 times whatever this is would equal 0. So what I'm going to do is I'm going to set each binomial, d minus 7, equal to 0. And this other binomial, d plus 4/3, equals 0. I'm going to solve these two equations, and that will get me the two places that this graph hits the x-axis. So that would be at d equals 7. And d equals negative 4/3. Now you may notice it's just the opposite of what's inside the binomial, but it doesn't always work that way. For example, let's say in number 12. Number 12, the two binomials, this first one makes sense. If I make x plus 6 equal to 0, then x just has to equal the opposite of 6, so x equals negative 6. This one's a little, the first one that was a little more complicated because we have a coefficient in front of the x. So we have to do 3x plus 1, oh that's bad, equals 0. So solve that equation. So now we'll have the two values for x that will make this whole function equal 0. So if x equals negative 1/3, then if x equals negative 1/3, then over here I would have negative 1/3 plus 6. Well, that just equals 5 2/3. That's not 0. But on this side, I would have 3 times negative 1/3, which would give me negative 1. And negative 1 plus 1 does equal 0. So this binomial would equal 0. And I'd be doing 0 times 5 2/3 equals 0. If I use x equals negative 6, then over here I would have 19, because 3 times, sorry, I apologize, negative 17, that's better, don't forget your integer rules, negative 17. And in the other side, I'd have negative 6 plus 6 is 0. So I'd have negative 17 times 0 equals 0. So these are the two values for x that would cause the whole function to be 0. They're called the zeros of the function. So here's that section I was telling you about in your textbook on page 520 that has several examples, and all you have to do is take each binomial and make them an equation equal to 0, solve that equation, and you will have the zeros of the function, or you will solve the equation. So that's how you do that. Anyway, we're not finished with 8.4. We have more to do, but for now, that's a good introduction. Thanks for watching.